We are continuing today with this question where we have the first question to be: a curve has an implicit equation 4y squared minus 2xy minus x squared plus 11 equals 0. Find the equation of the normal to the curve at the point 3, 1. No, then the second question also has it that a curve has an implicit equation x squared plus y cubed plus 3y squared plus 3y minus 6x equals 0. Find an equation of the normal to the curve at the point 3 minus 3. So from the previous lesson, we derived that to find the slope of the tangent, we find the first derivative of the function, which is our dy dx. Now, with this question, to find the slope of the normal, we find the negative reciprocal of the slope, of the slope of the tangent, which means that if we have the slope of a tangent to be a over b, then that of the normal is going to be a negative reciprocal of this, which is going to be negative b over a. So we'll proceed in solving this question where you see how we have to apply this concept over here. So from that question, you realize that the equation of the curve is given to us by, is given to us by 4y squared minus 2xy minus x squared plus 11 equals 0. This is the equation of the curve. Then we now proceed to find what? The point. The point has been given to us, which is what? 3, 1. So our point here is 3, 1. So we first confirm that this point lies on the curve. By doing so, we put it inside to see if we put the point inside the equation to see if the result will surely be 0. Doing that, we are going to get 4 into bracket 1 square minus 2. This is what? First point is 3. So this is 3, 1 minus 3 square plus 11. This should be equal to 0. This is as 4. 2 times 3, this is 6. This is what? This is going to be 9. This is plus 11. Should be equal to 0. When we see this, 14 plus 11 over here is 15 minus 15, which is the same as 0. So we are right. It means that the point lies on the curve. We now proceed to find the derivative of the function, which shall be the slope of the tangent. Then we find the negative reciprocal of the slope of the tangent, which shall be the slope of the normal. Then, so this is going to give me, we find the derivative of this, which is d dx of everything here. 4y squared minus 2xy minus x squared plus 11. Okay, which is the same as a d dx of the distance as well. Alright, so finding that, the first, this is what in terms of y, so we are going to get 8y dy dx implicitly dy dx. This is minus, now 2x over here. We use the product rule over here where the 2x becomes the first term, the y becomes the second term. So this is 1 and this is my 2. We differentiate the first term, 2x, it becomes 2. Multiply it with the second term, which is y. We then add that to the second term, the derivative of the second term, which is y, and that is going to be what? Dy dx. We multiply that with the first term, which is what? 2x. But mind you, negative is multiplying every term over here. And this is minus, the derivative of this is 2x. Derivative of a constant is 0, which is equal to 0. Then we now expand this bracket. We have 8y dy dx minus 2y minus, so this is going to be minus 2x dy dx minus 2x as well over here, which is 0. We now put the terms that contain the dy dx together. Then this is going to give me 8y minus 2x into bracket, all into bracket, dy dx. You proceed to send the other terms to the right hand side, where we have minus. This is now become positive because it is negative here. This is 2y plus 2x. You make our dy dx the subject, which is now going to give us 2y plus 2x all over 8y minus 2x. Alright, we have now gotten the slope of the tangent. So let's fix in the point over here into the slope to see the actual value. So this is going to give me 2 into bracket. The y value over here is 1. This is plus 2. The value of x over here is 3. This is over 8 multiplying. This is 3 minus 2 multiplying 1. Okay, now so we have to interchange it. So here is y over here is actually y over here is 1, so 8y, so 8y minus 2, this is what, 3. Alright, so that is going to give me my dy dx, which is going to give me, this is 2 plus 6 all over 8 minus 6. Okay, this is the same as 8 on 2, which is 4. Now we find the negative reciprocal of this, which is going to give a minus 1 over 4, which is actually equal to what? The slope of the normal. The slope of the normal to the curve. Then let's now find the equation of this normal. We know that the equation of a line, the equation is given to us by y minus y naught, which is equal to what's the gradient or the slope, which is 1 minus 1 over 4, then x minus x naught. Alright, we now fix in our points. Our y naught over here is 1, so we have y minus y naught is 1, which is equal to minus 1 over 4 into bracket x minus 3. So this is going to give us, to get rid of the fraction, we get 4y minus 4. This is going to give us minus 1 into bracket x minus 3. This results in 4y minus 4 minus x minus 3. When we resolve everything, we are going to get the equation of the normal to be 4y plus x minus 7, which is equal to 0. Then we now proceed to solve the second equation, which is here. Okay, then we over there, let's put this here. Okay, the equation of the second question of the curve is given to us by, okay, this is x to the power 3 plus y to the power 3 plus 3y squared plus 3y minus 6x, which is giving us 0. And then the point giving us is 3 minus 3. So from here, you can verify if the point actually lies on the curve. So from here, it actually lies on it, where you can confirm if it lies on it. Alright, so let's proceed by finding what the slope of the tangent of this curve. Okay, this is going to give us the derivative of the term here. This is the d dx of the whole term, x to the power 3 plus y to the power 3 plus 3y squared plus 3y minus 6x. This is equal to still the d dx of the constant here is 0. Alright, so when we find the derivative of this with respect to x, we are having 3x squared plus 3y squared dy dx. This is plus 6y. This is 6y dy dx plus 3 dy dx minus 6 is equal to 0. We now proceed by gathering the terms that contain the dy dx, where we are going to have 3y squared plus 6y plus 3 all into bracket multiplying dy dx, which is all equal to, we send the other terms to the right hand side. 3x squared to the right hand side becomes minus 3x squared plus 6. All right, then we make our dy dx the subject, and this is going to give me what? This is going to give me minus 3x squared plus 6 all over 3y squared plus 6y plus 3. Now this is going to be what? The slope of the tangent. So let's put in the values of the points over here into this slope, and this is going to give me minus 3 squared plus 6 all over 3, y is minus 3 squared plus 6 minus 3 minus 3, and this is plus 3. Okay, so that is going to give me my dy dx is equal to, this is minus 3 into bracket 9 plus 6 all over 3 into bracket 9 minus 18 plus 3. So let's see what that gives us. That should give us, so we have this is going to be what? Minus 27. My dy dx is going to be minus 27. All right, this is minus 27 plus 6 all over 27 minus 18 plus 3. Then our final answer is going to be minus 7 on 4, which is what? Minus 7 on 4, which is actually the slope of the tangent. So we now have to look for the slope of the normal to the curve, which is given as the negative reciprocal. So this is what? The slope of the tangent. Okay, the slope of the tangent. All right, so over here we find the negative reciprocal, which is 4 over 7. Will result, this is going to give us what? The slope of the normal or to the curve. Okay, then we proceed to find the equation of this normal, which we now have y minus y naught is equal to this, my slope over here. So let's represent that with s. Okay, multiplying x minus x naught. With the same point in concern, we have y minus the y naught, which is minus 3. This is going to be equal to my slope, which is what? 4 on 7 multiplying x minus 3. This is y plus 3 is equal to 4 over 7 x minus 3. Then we get rid of the fraction. We have 7y plus 21, which is equal to 4 into bracket x minus 3. We resolve this further. We are getting 7y plus 21 is equal to 4x minus 12. Our final equation of the normal to the curve is giving us 4x minus 7y minus 33 is equal to 0. Thank you. Don't forget to like, share, and subscribe, and let others as well access this video.